This is Algebraic Expressions Part 3. We're going to be talking about like terms and simplest form. Like terms are terms that have the same variables raised to the same exponents. Constants can also represent like terms. So when I have an algebraic expression like this one, the first thing I want to do is make sure it's written completely in addition. So I'm going to rewrite this one, 3y plus 6 plus 2 plus negative 7y. Now I can start looking for like terms. So the first pair I see both have the variable y. I've got 3y and negative 7y. So that is one pair of like terms. I also have a pair of constants. 6 and 2 are both constants, so they also represent a pair of like terms. When we're trying to put any algebraic expression in simplest form, the rules are it's in simplest form when we no longer have any like terms and we have no parentheses in our problem. So currently, if I go back to this problem, it's not in simplest form right now because I know there are some like terms in this algebraic expression. But if I combine those like terms, I can simplify. So I had my 3y and my negative 7y. And if I combine those two together, these guys will become negative 4y because 3 and negative 7 combine to give us negative 4. I can also combine my constants, 6 and 2, and these will combine to give me a total of 8. So negative 4y plus 8 is this expression in its simplest form. So let's take a look at a couple of our algebraic expressions and let's identify their terms and their like terms. So the first thing we need to do is take any algebraic expression and make sure we have it completely written as an addition problem. So this becomes 6x plus negative 3 plus negative 8x plus negative 2x. Now, when I'm looking for some terms, they're just the things that I'm adding. So my terms here would just be 6x, negative 3, negative 8x, and negative 2x. Anything that I'm adding as a term. My like terms have the same variable raised to the same power, or we can have a pair of constants. In this case, the terms that I see that are alike are the ones that all have x values. So my like terms here are 6x, negative 8x, and negative 2x. Now, negative 3 doesn't have anybody that is also a constant like him, so he doesn't match with anyone. He doesn't have a like term in this problem. Let's take a look at another one. So I want to rewrite this as addition. I'm also going to add some 1s in front of my variables that don't have a number. So this is going to become 1z squared plus 7z plus negative 3z squared plus 1z. So my terms are just 1z squared, 7z, negative 3z squared, and 1z. So I see some like terms here. I've got the ones with the z squared, 1z squared and negative 3z squared. So 1z squared and negative 3z squared are a pair of like terms. But I also see some more like terms. I also have this guy with just a regular z and this guy with a regular z. So I've got another pair. I have also 7z and 1z as a pair of like terms. So while these two could be combined, these two could also be combined. Let's try simplifying some expressions. So always the first thing, I need to have them written as addition. So this is going to become 14 plus negative 3z plus 8 plus 1z. So I'm going to find some like terms. The first two I happen to see are 1z and negative 3z. So together, the two of those are going to become negative 2z. Because negative 3 plus 1 gives me negative 2. I also see some constants I can combine. I see 8 and 14. So 8 and 14 together are going to become 22. So negative 2z plus 22 is this expression in its simplest form. Notice these two cannot be combined. This guy has a z, this one doesn't, so I can't simplify anymore. Let's take a look at this one. So I'm going to rewrite it 3/4 y plus 12 plus negative 1.5 y plus negative 6. So the first two that I see that are alike are my y values here. 3/4 y minus 1/2 y. So together, these two are going to combine to give me 1/4 y. Then I also see some constants that I can combine, 12 and negative 6. And these two together are going to become just a positive 6, so plus 6. So positive 1/4 y plus 6 is this expression in its simplest form. In this case, we need to get rid of some parentheses. So I'm going to use that distributive property. And I'm actually going to multiply the 3 by my q and my 1. So I'm going to multiply into this parentheses with my 3. I'm going to get 3q plus 3 minus 4. Then I want to change this to addition. It's going to become 3q plus 3 plus negative 4. So in this case, there's nothing the 3q can combine with, but I do see that I can combine 3 and negative 4. So those two are going to become negative 1. And then, of course, I also have the 3q. So 3q didn't have anyone to combine with. He just stays 3q. So this problem in its simplest form is right here. Let's try this guy. I'm going to multiply in my negative 1/2. So I'm multiplying by a negative and taking half of something. So this one's going to become negative 3n plus negative half of 4 will become negative 2 plus 2n. So right now, this is already written as addition. I'm going to look to combine, and I see I've got two problems here with n's. So negative 3n and 2n is going to become negative 1n. This guy doesn't have anyone to combine with, so he's just plus negative 2. There's a little more simplifying I can do here. I don't really need to keep this 1. I call it the ghost 1. It can disappear. This can just be written negative n. And since I'm adding a negative here, I can also simplify this. When I'm adding a negative, I'm just subtracting 2. So here's my simplified version of my original expression. And here's our last problem. Each person in a group is buying a ticket, a medium drink, and a large popcorn. They're going to the movies. And we want to write an expression in simplest form that represents the amount of money the group spends at the movies. So first, we want to look at the prices of everything. And since they're buying tickets, I need to know tickets are $7.50. They're getting medium drinks, which are $2.75. And large popcorns are $4. I need to pick a variable here. They never told me how many people were actually in the group. So X is going to stand for the number of people in this group. And every single person is buying a ticket, a medium drink, and a large popcorn. So we need to write an expression for this. So they're buying a ticket, which is $7.50, times however many people are getting that ticket. $2.75. They're each getting a medium drink for $2.75, and they're each getting a $4 popcorn. Now we can simplify this. Since every single person is buying each of these, they all have the variable X. So if I combine them, My $7.50 and my $2.75 is going to be $10.25 plus my $4. I'm at $14.25 times X. So it's going to be $14.25 per person.